Hello students, welcome to this lecture one coordinate geometry. So in this lecture we'll discuss ncert exemplars problem one coordinate geometry. Okay, so let's get started. So in question number 1, so the distance of the point P of 2 comma 3 from the x-axis is what? Okay, so let us find the distance of the point P of 2 comma 3 from the x-axis. So we know that if x comma y is any point on the Cartesian plane in first quadrant, then x is perpendicular distance from y-axis and y is perpendicular distance from the x-axis. Okay, so we have given this point 2 comma 3 and we need to find the distance of the point P of 2 comma 3 from the x-axis. Okay, so here basically we need to find coordinate of the point P of 2 comma 3. So you can visualize this distance is basically distance from the y-axis and this distance is basically distance from the x-axis. Okay, and this distance is x coordinate and this distance is basically y coordinate, that is ordinate. Okay, so here for P of 2 comma 3 point, here the distance of the point P of 2 comma 3 from the x-axis, this is equal to coordinate of the point P of 2 comma 3, this is equal to 3. Okay, so here the correct answer is option number B. And now let us move to question number 2. So here we have to find the distance between the point A of 0 comma 6 and B of 0 comma minus 2 is what? Okay, so here basically the distance between 2 point x1 comma y1 and x2 comma y2 is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so now use this distance formula and simplify it. So since distance between the point x1 comma y1 and x2 comma y2 is equal to this, so here x1 is 0, y1 6 and x2 is equal to 0 and y2 is equal to minus 2. Okay, so therefore distance between A of 0 comma 6 and B of 0 comma minus 2, that is AB is equal to square root of 0 minus 0 whole square plus minus 2 minus 6 whole square, that is equal to square root of 0 minus of 8 whole square, that is equal to square root of 8 square, this is equal to 8. Okay, so the distance between the points A of 0 comma 6 and B of 0 comma minus 2 is 8. So here the correct answer is option number B. Okay, so you can also find by graphically. Okay, so here basically 0 comma 6 and 0 comma minus 2, these 2 points lie on the y-axis. Okay, so lie on the y-axis, and here you can directly find the distance between these 2 points by using this formula 6 minus of minus 2, that is equal to 8. Okay, so in option number B we have this value 8. So correct answer is option number B. Now let us move to question number 3. So the distance of the point P of minus 6 comma 8 from the origin is what? So we need to find the distance of the point P of minus 6 comma 8 from the origin. Okay, so let us find. So coordinate of the origin is 0 comma 0, that you know. Okay, so distance between the points x1 comma y1 and x2 comma y2, that is equal to d is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So here x1 this is minus 6, y1 is y1 is 8 and x2 is 0 and y2 is 0. Okay, so therefore the distance between point P minus 6 comma 8 and the origin is that is O 0 comma 0, that is PO is equal to square root of 0 minus of minus 6 whole square plus 0 minus 8 whole square, this is equal to square root of 6 square plus 8 square, that is equal to square root of 36 plus 64, that is equal to square root of 100, and this is equal to 10. Okay, so the distance of the point P of minus 6 comma 8 from the origin is 10. Okay, so here the correct answer is option number C. And now let us move to question number 4. So in question number 4, here we have to find the distance between the point 0, 5 and minus 5, 0. Okay. So here also we can use the distance formula. D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. And here x1, this is equal to 0. Y1, this is equal to 5. X2 is minus 5 and y2 is equal to 0. Okay, so therefore the distance between the points 0, 5 and minus 5, 0, this is equal to square root of minus 5 minus 0 whole square plus 0 minus 5 whole square, that is equal to square root of 25 plus 25, and this is equal to square root of 50, and this is equal to 5 times root 2. Okay, so therefore the distance between the points 0, 5 and minus 5, 0 is 5 times root 2. So here correct answer is option number B. Now let us move to question number 5. So if AOBC is a rectangle which three vertices are A of 0, 3, O of 0, 0 and B of 5, 0, then the length of its diagonal is what? Okay, so basically we have given AOBC, this is a rectangle, and we have given the three vertices of this rectangle. Okay, and we need to find the length of its diagonal. So you can see this figure. So here this is our AOBC rectangle, and the vertices of A, O and B are actually 0, 3, 0, 0 and 5, 0 respectively. Okay, so now length of the diagonal, that is AB, this is distance between the points A of 0, 3 and B of 5, 0. And since we know the distance formula, distance between the points x1, y1 and x2, y2, that is D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. And here x1, this is equal to 0, y1 this is equal to 3, x2 is equal to 5 and y2 is equal to 0. Okay, so therefore the distance between the points A of 0, 3 and B of 5, 0, that is AB, this is equal to square root of 5 minus 0 whole square plus 0 minus 3 whole square, and this is equal to square root of 25 plus 9, and this is equal to square root of 34. Okay, hence the required length of its diagonal is square root of 34 units. So here the correct answer is option number C. Okay, so option number C is here correct answer. Now let us move to question number 6. So in question number 6, here the perimeter of a triangle with vertices 0, 4, 0, 0 and 3, 0 is what? Okay, so we firstly plot the given points on a graph paper and join them to get a triangle. Okay, so if we plot these points, then you will get this type of triangle, and the vertices A, O and B are 0, 4, 0, 0 and 3, 0 respectively. Okay, so secondly we determine the length of the each sides by using the distance formula. So we can find the length of each side. We can find OV, AB and AO. Okay, so further adding all the distance of a triangle to get the perimeter of a triangle. So now perimeter of triangle AOB, that is actually sum of the length of both sides. Okay, that is actually equal to D of length of AO, length of OB and length of AB. So since distance between the points x1, y1 and x2, y2, that is D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so this is equal to distance between A 0, 4 and O 0, 0 plus distance between O 0, 0 and B 3, 0 and distance between A 0, 4 and B 3, 0. Okay, so this is equal to square root of 0 minus 0 whole square plus 0 minus 4 whole square plus square root of 3 minus 0 whole square plus 0 minus 0 whole square plus square root of 3 minus 0 whole square plus 0 minus 4 whole square. Okay, and if you simplify it, then you will get this is equal to 7 plus square root of 25, that is equal to 7 plus 5, and this is equal to 12. Okay, hence the required perimeter of the triangle is 12. So here the correct answer is option number B. Okay, and now let us move to question number 7. So in question number 7, we need to find the area of a triangle with vertices A of 3, 0, B 7, 0 and C 8, 4 is what? Okay. So here the area of the triangle whose vertices are A of x1, y x1, y1, B x2, y2 and C x3, y3 is given by half of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. So use this formula and simplify it to get the result. So area of triangle ABC whose vertices are given to us. Okay. So here x1 is 3, y1 0, x2 7, y2 0 and x3 8 and y3 4. So if we put these values in this formula, then we get the area of the triangle, that the delta is equal to 1 by 2 times 3 times 0 minus 4 plus 7 times 4 minus 0 plus 8 times 0 minus 0, and this is equal to 1 by 2 times minus 12 plus 28 plus 0 modulus. Okay, and this is equal to modulus of 1 by 2 times 16, that is equal to 8. Okay, hence the required area of triangle ABC is 8. Okay, so here in option number C we have 8, so correct answer is option number C. I think this is clear to you. Now we can move to question number 8. So in question number 8 here we have the points minus 4, 0, 4, 0 and 0, 3 are the vertices of a which triangle? Okay. So here we let A minus 4, 0, B 4, 0 and C 0, 3 are the given vertices. Okay. And secondly, we know distance formula D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay. So if we find the distance AB, that is equal to square root of 4 minus 4 whole square plus 0 minus 0 square, that is equal to square root of 4 plus 4 whole square, that is equal to square root of 8 square, this is equal to 8. Okay, and distance between B 4, 0 and C 0, 3, that is BC, this is equal to square root of 0 minus 4 whole square plus 3 minus 0 whole square, and this is equal to square root of 16 plus 9, and this is equal to square root of 25 is equal to 5. Okay, and the distance between A of minus 4, 0 and C 0, 3, that is AC is equal to square root of 0 minus 4 whole square plus 3 minus 0 whole square, that is equal to square root of 16 plus 9, and this is equal to square root of 25 is equal to 5. Okay, so here since BC is AC, okay, BC is equal to AC, and hence triangle ABC is an isosceles triangle because an isosceles triangle has two sides equal. Okay, so here we get two sides equal, so therefore this triangle this triangle whose vertices are minus 4, 0, 4, 0 and 0, 3 is a isosceles triangle. Okay, so here the option number B correct answer. Option number B is here correct answer. So now let us move to question number 9. So in question number 9, here the point which divides the line segment joining the points 7, minus 6 and 3, 4 in ratio 1:2 internally lies in the which coordinate? Okay, so we need to find first of all the coordinate of the point P of x, y. So if P of x, y divides the line segment joining A of x1, y1 and B of x2, y2 internally in the ratio m:n, then x is mx2 plus nx1 divided by m plus n, and y is equal to my2 plus ny1 divided by m plus n. Okay, and here given that x1 this is equal to 7, y1 this is equal to minus 6, x2 is equal to 3, y2 is 4 and m is equal to 1 and n is equal to 2. Okay, so therefore the x is equal to 1 into 3 plus 2 into 7 by 1 plus 2, y is equal to 1 into 4 plus 2 into minus 6 divided by 1 plus 2. Okay, so it implies x is equal to 3 plus 14 by 3 and y is equal to 4 minus 12 by 3. And it implies x is equal to 17 by 3 and y is equal to minus 8 by 3. So x, y, this is equal to 17 by 3 and y minus 8 by 3. Okay, and this coordinate lies in fourth coordinate. Okay, so in fourth coordinate, the x coordinate is positive and y coordinate is negative. Okay, so this coordinate 17 by 3 and comma minus 8 by 3 lies in fourth quadrant. Okay, so here the correct answer is option number D. Now let us move to question number 10. So the point which lies on the perpendicular bisector of the line segment joining the points A of minus 2 comma minus 5 and B of 2 comma minus 5 2 comma 5 is what? Okay, so here we know that the perpendicular bisector of the any line segment divides the line segment into two equal parts. Okay, that is the perpendicular bisector of the line segment always passes through the midpoint of the line segment. So here we will use midpoint formula. So midpoint of the line segment of joining the points A of minus 2 comma minus 5 and B 2 comma 5. This is equal to minus 2 plus 2 by 2 comma minus 5 plus 5 by 2. This is equal to 0 comma 0. Okay, since the midpoint of any line segment which passes through the points, so x1 comma y1 and x2 comma y2, this is equal to x1 plus x2 by 2 and comma y1 plus y2 by 2. Okay, hence the 0 comma 0 is the required point lies on the perpendicular bisector of the line segment. Okay, so here the correct answer is option number A. And now let us move to question number 11. So the fourth vertex D of a parallelogram ABCD whose three vertices are A minus 2 comma 3, B 6 comma 7 and C 8 comma 3 is what? Okay, so basically we have given three vertices of a parallelogram and we need to find fourth vertex D. Okay, so let us find. So here firstly consider the fourth vertex of a parallelogram B dx4 comma y4. Okay, and secondly determine the midpoint of AC and BD by using distance formula, using midpoint formula. Okay, x1 plus x2 by 2 comma y1 plus y2 by 2. Okay, and in third one you further you are equating both points and get the required coordinates of the fourth vertex. So here we first let the fourth vertex of the parallelogram, that is x4 comma y4, and LM be the middle points of A, C and BD respectively. So L of coordinates of L will be minus 2 plus 8 by 2 comma 3 plus 3 by 2, that is equal to 3 comma 3. Okay, and since the midpoint of a line segment having point x1 comma y1 comma and x2 comma y2, that is equal to x1 plus x2 by 2 comma y1 plus y2 plus y2, and hence m is equivalent to 6 plus x4 by 2 comma 7 plus y4 by 2. Okay, and since ABCD this is a parallelogram, therefore the diagonals AC and BD will bisect each other. Okay, hence L and M are the same points. So therefore we get 3 is equal to 6 plus x4 by 2 and 3 is equal to 7 plus y4 by 2. Okay, and it implies 6 is equal to 6 plus x4 and 6 is equal to 7 plus y4. So it implies x4 is 0 and y4 is equal to 6 minus 7, that is equal to minus 1. Okay, hence the fourth vertex of the parallelogram ABCD is D is equal to 0 comma minus 1. Okay, the fourth vertex of this parallelogram is equal to 0 comma minus 1. So here the correct answer is option number B. Now let us move to question number 12. So if the point P of 2 comma 1 lies on the line segment joining the points A 4 comma 2 and B 8 comma 4, then which option will be correct? So here given that the point P 2 comma 1 lies on the line segment joining the points A 4 comma 2 and B 8 comma 4. So which shows in the figure, here this point is 2 comma 1, this point is 8 comma 4 and here is 4 comma 2. So now the distance between A 4 comma 2 and P 2 comma 1, that is AP, this is equal to square root of 2 minus 4 whole square plus 1 minus 2 whole square. Okay, since distance between two points x1 comma y1 and x2 comma y2, that is D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square, and this is equal to square root of minus 2 whole square plus minus 1 whole square, that is equal to square root of 4 plus 1, and this is equal to square root of 5. Okay, so the distance between A of 4 comma 2 and B 8 comma 4, that is AB is equal to 2 times root 5. And distance between B point and P point, that is BP, is equal to square root of 8 minus 2 whole square plus 4 minus 1 whole square, and this is equal to square root of 6 square plus 3 square, and this is equal to square root of 36 plus 9, and this is equal to square root of 45, and this is equal to 3 times root 5. Okay, so therefore the AB, this is equal to 2 times root 5, and BP, this is equal to 3 times root 5, and AP, this is equal to this is equal to, so you get AB is equal to 2 AP, so AP is equal to AB by 2. Okay, hence the required condition is AP is equal to AB by 2. Okay, so the AP is equal to AB by 2, so here AP is equal to 1 by 2 AB, so here the option number D is correct answer. Okay, so now let us move to question number 30. So if P, this coordinate A by 3 comma 4 is the midpoint of the line segment joining the points Q minus 6 comma 5 and R minus 2 comma 3, then the value of A is what? So here given that P coordinates of P are A by 3 comma 4, and this point is the midpoint of the line segment joining the points Q minus 6 comma 5 and R minus 2 comma 3, which shows in the figure given below. Okay, so here this figure, this point is Q, this is P, and this is R. So therefore the midpoint of QR, this is equal to P of minus 6 minus 2 by 2 comma 5 plus 3 by 2, that is equal to P of minus 4 comma 4. Since the midpoint of the line segment having points this and this, so this formula we can use, but midpoint of this is given, so A by 3 comma 4, this is equal to minus 4 comma 4, and if we comparing the coordinates, then we get A by 3 is equal to minus 4, and this implies A is equal to minus 12. Okay, hence the required value of A is minus 12. So here the correct answer is option number B. Now let us move to question number 40. So the perpendicular bisector of the line segment joining the points A of 1 comma 5 and B 4 comma 6 cuts the y-axis at what point? So firstly, we have to plot the points of the line segment on the paper, on a graph paper, and join them. Okay, so if we plot the points, then you will get this type of graph. So this point is A 1 comma 5 and this is B 4 comma 6, and here this line passes through the point 5 by 2 comma 11 by 2. This is actually a perpendicular bisector of this line. Okay, so we know that the perpendicular bisector of the line segment AB bisect the segment AB, that is perpendicular bisector of the line segment AB passes through the midpoint of AB. So here the midpoint of AB is basically 4 plus 1 by 2 comma 6 plus 5 by 2, that is 5 by 2 comma 11 by 2. So now we draw a straight line on a paper, passes through the midpoint P. We see that the perpendicular bisector cuts the y-axis at the point 0 comma 13. Okay, so here this line perpendicular bisector cuts the y-axis at the point 0 comma 13. So here the correct answer is option number A. And now let us move to question number 15. So the coordinates of the point which is equidistant from the three vertices of the triangle AOB as shown in the figure is what? So we have given this figure, and here we have given the coordinates of A is 0 comma 2A and B 2x comma 0. Okay, so firstly consider the new point B for P of H comma K, and secondly we can use the distance formula, and further if we solving two terms at a time and solving them to get the required point. So here we let the coordinates of the point which is equidistant from the three vertices O 0 comma 0, A 0 comma 2A, and B 2x comma 0, and is P of H comma K. Okay, and here then P of A, this is equal to PA, this is equal to PB. So it implies PO square, this is equal to PA square, this is equal to PB square. And by distance formula, this is the square root of h minus 0 whole square plus k minus 0 whole square. This is equal to square root of h minus 0 whole square plus k minus 2y whole square. Okay. And this is equal to square root of h minus 2x whole square plus k minus 0 whole square whole square. And it implies h square plus k square. This is equal to h square plus k minus 2y whole square is equal to k minus h minus 2x whole square plus k square. Okay, and taking the first two equations, then we get y is k, and taking first and third equation, then we get x is h. Okay, so therefore required points h comma k is equal to x comma y. So the required points, this is equal to h comma k is equal to x comma y. And now let us move to question number 16. So if a circle drawn with origin as the center passes through the 13 by 2 comma 0, then the point which does not lie in the interior of the circle is what? So here it is given that center of the circle is 0 comma 0 and passes through the point 13 by 2 comma 0. Okay, and we know distance formula. So radius of circle is distance between 0 comma 0 and 13 by 2 comma 0. So if you use the distance formula, then you will get this equal to 6.5. So if point lie outside one or inside the circle of the distance of it from the center of the circle is greater than equal to the greater than equal to or less than equal to the radius of the circle. Okay, so you can check now option. So in option A, if you find the distance between 0 comma 0 and minus 3 by 4 comma 1, then you'll get 1.25, that is less than 6.5. So the point minus 3 by 4 comma 1 lies interior to the circle. And in option number B, if you check the distance between 0 comma 0 and 2 comma 7 by 3, that is equal to 3.1, this is also less than 6.5. So the point 2 comma 7 by 3 lies inside the circle also. And in option number D, we have this point 5 comma minus 1 by 2. So if you find the distance 0 comma 0 and 5 comma minus 1 by 2, then you'll get 5 comma 02, that is less than 6.5. Okay, so the point 5 comma minus 1 by 2 lies inside the circle. And now if we check distance between 0 comma 0 and minus 6 comma 5 by 2, that is equal to 6.5. And so the point this is lie on the circle, that does not lie interior to the circle. So the option number D is correct answer. Okay, so I stop here this lecture. Thank you very much to all of you.